Hello guys, welcome to the channel. Today we are going to discuss a question of IIT JEE which has come in 2008. Okay, the question says here figure shows three resistor configurations R1, R2, R3 as shown in the figure like this. R1, R2, R3 are three different configurations which are connected a 3-volt battery in each case. If the power dissipated by the configuration R1, R2, R3 are P1, P2, P3, like let us say the power dissipated in this circuit is say P1, in this one is say P2, in this one it's say P3. Okay, he is asking the relation between P1, P2, P3. I mean, which is more, which is less, like that. I mean, P1 is greater than P2, which is greater than P3, something like that. Let us look at this question, which is actually interesting question. Many people will look at the question and simply they give up, but this question actually is very interesting and easy. Let me tell you. So first of all, in order to solve this kind of questions, we take power. We need to know what is power. Power actually can be defined as voltage times current, or you can take when square of voltage divided by resistance, or current square multiplied by the resistance, I mean equivalent resistance in that circuit. So these three formulas we can use. But if you see, I mean in all these three cases, resistance is there and voltage has been given in each case. So it is appropriate to take this formula for power, and let us do this now. Okay, so before that, I mean 3 volts is the voltage or potential difference across for all these three cases. We need to find out R equivalent for each case, right? Now how to find this? Maybe let us come from the last one. It will be easy actually if you talk about this guy. So basically here these two resistors are connected in series. So 1 and 1 ohm actually is connected in series. So I can say the equivalent resistance for this one is nothing but 2 ohms. Here also it is connected in series. Okay, I can say that it is 2 ohms again. Now these 2 ohms and these 2 ohms are connected in parallel. When you have two identical resistors connected in parallel, the equivalent resistance will become half of it. That means 2 times 2 ohms divided by 2. So you will have one single resistor here which has a resistance of 1 ohm. Understand? Now I mean you can remove all these resistors. Fine. Now you have got this 1 ohm resistor along with this 1 ohm resistor. Both of them actually are in series. Okay. So once they are in series, you can say that the equivalent resistance for this whole circuit is 2 ohms. Okay, R3 will be is equal to 2 ohms. That's simple, isn't it? Now here, so if you look at this guy, actually these two resistors are in series. You can say 1 and 1, 1 plus 1, that is nothing but 2 ohms. And here also again it is 1 and 2, 2 ohms, right? So if you look at these three resistors now, 2 ohms, 1 ohm and 2 ohm actually are in parallel. So now if you find out 1 by R2, that will be is equal to 1 by 2 plus 1 by 1 plus 1 by 2, right? 1 by 2 plus 1 by 1 plus 1 by 2. That's it now. The LCM of this guy will be 2, and here 1. Here you have to multiply with 2 and 2 in the numerator and denominator. You get 2 here and 1 here. So it is 4 by 2. Many students just leave the question. I mean by taking 2 ohms. Then they will say that okay fine, P2 and P3 are same, but actually they'll forget about reciprocating it. So it's actually 1 by 2 ohms. Okay. Now let's find out R1. So here to solve this kind of questions, we can take a potential method. What is that? Potential method. So this potential method actually says about here, if the EMF of the cell is actually 3 volts, that means that the potential difference between this higher potential plate, lower potential plate is 3. You can take a higher potential plate as 3 volts and lower potential plate as 0 volts. So here there is no component in between, so it will become 3 volts here. Okay, here also 3 volts, here 0, here 0, here 0, here 0. And if you talk about this, at this location also it is 3 volts, at this location also 3 volts. So let me take this location, I mean at this location, let us say you have got because of this resistor there will be some potential drop. Can I say that as X? Okay, now actually from this one you supposed to have one more, I mean there are definitely some other resistance. I mean because current is flowing in this path, definitely there will be some potential drop. Actually, frankly speaking, here what will be the potential drop across after 1 ohm resistor? Here also after 1 ohm resistor only. So you can say here also the potential is same. So that means there will be here this resistor is in between two same potentials. So you can say there will be no current through this. You can neglect that. Otherwise, you can also take it as a Y when different potential, and let us apply this potential method. So that is A, B, X and Y here. So let's just look at this guy. Let us take 3 volts is actually at A point, and 0 volts is actually at B point, let us say. Okay, now this resistor is in between 3 and Y. 3 and Y means A and Y, right? Now take this resistor. This resistor is in between 3 and X. 3 and X. Now this resistor is in between X and Y. Since all the resistors are same, we don't have to worry about it. And now this resistor is in between X and 0. X and 0 means this one, no? X and B. Next, this resistor is in between Y and 0. Y and 0 means Y and B. Okay. Now, if you look at one thing here, actually this is 1 ohm. This is 1 ohm. Here also 1 ohm. Here also 1 ohm. So actually, if you see properly, this is actually Wheatstone bridge case, and that too balanced Wheatstone bridge. Here you can see R1 by R2 is equal to R3 by R4. Now here 1 by 1 is equal to 1 by 1. So basically in that way what will happen? So these two, in this resistor there will be no current passing, or you can say these two points are at the same potential. The same thing that we have discussed here, X and X, X and X. Anyway, so here there will be no current passing through this, you can forget about that. Then if you see properly, these two resistors are in series. These two resistors also in series. So you can say 1 plus 1, 2 ohms. Here 1 plus 1, 2 ohms. Just now we have discussed in the first R3 case also that if two identical resistors are connected in parallel, then 2 and 2, it will become half of it. That means R1 will be 2 by 2, that is 1 ohm. Clear? So if you see properly, so R1 is 1 ohm, R2 is 2 ohms, 1 by 2 ohms, and R3 is actually 2 ohms, right? So R3 is greater than, R1 is greater than R2. This is the relation between resistances. Now if you see properly, here voltage is same for all of them, then you can forget about this. You can say that power is directly proportional to 1 by R. So the relation will become exactly ulta, or I can say completely reciprocated. So this one, like you'll have P2 is greater than P1 is greater than P3. So this is the answer. Okay. So option C was the answer actually in the given question paper. Okay. Thank you very much, guys.